Hey, this is my video for Lab 2. I guess I'll just start off by showing you guys the circuit. Here we have our Wheatstone bridge just built onto the breadboard. Nothing really that special, just all the resistor connections. And these probes are hooked up, this one to the end of R1, the one I'm wiggling here, and this one to the end of RS. It's easy to see on the diagram. That's basically just a potential difference across R3, which is kind of what we're looking for and trying to minimize. Um, and these probes here, they're just attached to ground so that the probe readings are relative to ground, which is important for when you subtract them later. Okay, so next I'll show you the waveform and exactly what happens when we change the value in the potentiometer here. Here's the waveform on the screen. Right now it's set to, I think, 20 millivolts a division, so it's going to be very sensitive when I start changing it. Should be able to see it very clearly and quickly, yeah. So there we go. As I'm changing the resistance, the peak-to-peak values are changing. Right now we're at about 200 millivolts. So just showing that behavior. Let's see, what else do I have to go over? Okay. Yeah, so if you just saw the waveform, you can see how by changing the resistance value you can get it very close to zero, which is actually pretty close right now even, but you can balance it out here. And the averaging effect is already on right now, but you just have to go into time and set the average to 20, and if you don't do that, so if you were to just say, like, I'm gonna write none, or maybe it has to be zero, yeah, none works, you just see it gets much more noisy. And this is very hard to see, but the peak to peak is fluctuating a lot very quickly. So if you really want a better idea of like what the peak to peak of your signal is, you kind of have to use an average or take some kind of steps to reduce noise. Okay, so I think that's basically everything. Thank you guys, and see you in class.